we're looking at a brief introduction to vectors today. Vectors are something that gives us not only just a numerical quantity, but also a direction as well. So we're going to look at both magnitude and direction for all these problems. And that's really important because naked numbers are not good. Now, vectors are normally represented with a directed line segment. Sometimes we've called this array before. So if we're going from P to Q, I call a directed line segment PQ that starts at P and goes to Q. And if I use this kind of double absolute value here, that means the length or the magnitude of that vector. So we start by looking at pictures. We want to draw how these vectors will look. Well, here's U and V up here. If I want to do the opposite of U, well, it's like I've gone somewhere and now I need to make my way back. So the magnitude should be the exact same, but the direction should be the complete opposite. So that's what U looks like, and there's what negative U would look like. Now, for 3V, this means that, well, if that's what V looked like, something like this, well, 3V means I've done it not once, not twice, but 3 times. So I need to go that same direction, and then keep going, and then keep going. I have to go off the screen here. That's how far this would be. 3V going forever, well, not forever, but 3 times that length. Now, linear combinations work the same way. So I want to first go to where U was, and I'm going to go tail to tip. What that means is I'm going to take this for V and put it right where it is, that same direction, but start it instead of at the origin, start it where U ended. So that's where U is. I'm going to start V right from there. So there's V. And then my resultant is whatever the connection is. So that's what U plus V would be. Same way if I do subtraction. I go up where U was, and now for minus V means I'm going the opposite direction, so I'm going down like this. My resultant should be something that looks like that. That's what U minus V would be. So this last one, combining with a scale factor as well. So there's U minus 1/2 V. So minus V came down this way, but only half the distance this time. So about from there, approximately. So connect, that's where U minus 1/2 V would go. So that's what they look like in picture form. Now we need to start looking at the mathematical portions to it. We're going to find different forms. A component form is the big part of it. Component form of a vector means different parts of a vector. And it's going to look an awful lot like ordered pairs, slope, and maybe even some distance formula in there from the past. So what we're going to use is these angle brackets right here. These angle brackets are what we use to represent a vector. So instead of parentheses with an ordered pair, all we'll do is these brackets for vectors. And these are essentially the x's and the y's, just like in a regular ordered pair. Same here, an x value and a y value. This in your end is your component form. This is where your component vector would be. And then when we do the distance formula here in the end, this is going to be what the length of our component vector will be. And this should look just like distance formula as well. Add up or subtract the x's and square them, subtract the y's and square them, take the square root. To show you what this looks like in terms of a problem, find the vector with its initial point right there. Well, first I'm going to just draw a quick graph of this, see if I have it. Well, I'll just go through the entire problem and show you how we do this. Now we'll go through one at a time, because I like to. So we would first try to just judge where these points would be. So 1, 2, 3, down -6, so somewhere around here is where P would be at 3, -6. And then up here somewhere is where Q, the terminal point of -2, 4 would be. So my vector, my directed line segment would look something like that. So we want to first find what the component vector is. So V, not the length of V, apologies. Just V will be, we're going to have these angle brackets, and we need to go in a specific order. We need to go from where we finished to where we started. So the x values of where we finished to where you started. You finished at the x value of -2, you started at 3, and the y values, you started at 4, and you ended at -6. If we simplify that, that's just -5, comma, 10. That is your component vector right there. Now, the way you can see that from the picture is look at it just in terms of x's and y's. Break it down into its components of x and y. For my x's, I have a distance of 5 right here. And for my y is a distance of 10. Now, it's directed though. So I went to the left 5, that's negative. I went up 10, that's positive. That's why we have negative 5, positive 10. And when we do our length of that component vector v, what I'm going to do now is the square root of these two numbers we just found, negative 5 squared and 10 squared. Well, that's going to be the square root of 125, which if we simplify it will be 5 times the square root of 5, because we'll have a 5, we'll have a 5, and another 5. There's a pair, only a single can make it out. That's why it's 5 square roots of 5. And how that relates here to our picture, we have a right triangle. If you use Pythagorean theorem, a squared plus b squared equals c squared. There's your a, there's your b. I take the square root of it, and that's how I would get c. So that's how that one works for those. We want to do one more example to make sure we can get these right. I would say pause the video, give it a try, see if you can find the component vector and the length. Start it back up when you want to check your answer. Alright, what you should have gotten for your component vector, you should have gotten that the vector v is equal to difference of the x's first, so negative 1 minus 3, so n to start, and then for the x's, 4 minus a negative 2, which means I'm going to have negative 4 for my x component and positive 6 for my y component. That means my length is just going to be the square root of negative 4 squared plus 6 squared. Make sure you have a negative 4 in parentheses in your calculator, so you should get the square root of 52, which will equal 2 square roots of 13. So that's an introduction to vectors. We're going to go into unit vectors coming up soon, and some other components, especially, of course, direction, which direction you're actually going.